Okay, thank you very much. So I will continue with give some thoughts on carbon capture and storage. And I will start by showing one positive slide, and then I will show a couple of very depressing slides, and then I will try to finish up with a bit more positive message. So here's the first positive slide I have, and as you can see, over the last more than 10 years, there's been an extremely positive trend and very high rate of increased investments in renewable energy sources. So that is mainly wind power and solar power and some biomass, of course. What is more depressing, however, is that if you see the share of fossil fuel in the total share, global, these are global figures, and the total share of energy consumption, it stayed exactly flat. Ironically, with these statistics we have here, it's actually increased 0.5%. So the message from this to me is, of course, that most of this renewable is a result of some sort of support mechanism, which I'm not against. It's of course important. Nevertheless, in order to change the trend of the share of fossil, we need, as Anders pointed out, obviously a price of the carbon emissions. So that's very important. I'll come back to that later. You can also see this a bit, again, depressing or terrifying. These are countries that all have large assets of fossil fuel resources, so coal, oil and gas, and mainly coal. And on the left hand you can see the trend in these countries in the development over the same period, 2004 to basically now, 2014. And you can see the upper graph to the left is China, where all the shit that we buy is produced. No, good things as well. Even the bicycles, I guess, are made in China, and all iPhones and so on. And you can compare that to the trend in these countries of the non-hydro renewable energy sources, that is the expansion in mainly then in wind and solar. So of course, you've probably seen these very steep increases in the diffusion of wind and solar. But if you plot it as the primary energy, meaning that you also have industry and transportation sector, and plot it on an energy base in these are million-ton oil equivalent, you get this rather depressing, very small. Ironically, the only country that combines large assets with fossil fuel is a lower graph there, that's the United States. So that's a bit ironic considering the current political thing there. This brings me to the rationale of CCS, why that is something that we most likely need. And Anders has already mentioned the second point there, that we need negative emissions, net negative emissions globally, and also according to the Swedish target. The upper one, I think, is the most one. There is only two ways, most important one, there are only two ways to deal with this, either to leave the fossil fuels in the ground or to apply carbon capture and storage. There's nothing else. And then the last point there is, of course, that the carbon-intensive industry that also come up in the discussion before, even in Sweden, require, cement, for instance, is very difficult to get around carbon capture and storage if you are to comply with the targets, including the Swedish one. I should also point out that carbon capture and storage is not replacing other measures. It's part of an overall mitigation portfolio. In Scandinavia, as Anders showed, we have large point sources, both fossil and biogenic. They're also, in the carbon capture and storage perspective, good because they are mostly located around the coastline, so you can use ship as transportation measure to the storage locations. Typically, these are some examples of large centralized storage point sources of emissions. So we have, of course, biogenic combined heat and power plants. We have refineries, we have pulp and paper, We have cement factories and some other ammonia factories and so on. And in fact, in Norway, they're already working at assessing carbon capture and storage at the Norcem, which is a Heidelberg cement factory in Breivik, at Yara in Porsgrunn, an ammonia factory, and then to the far left down there, combined heat and power plant, or actually in a waste incineration plant, but in a combined heat and power scheme. We also have, as Anders pointed out, large storage volumes quite nearby. These are the colored areas there. So it's mainly, we don't have any on storage sites, but we have around in the North Sea, but also in the south, and some in the Botnia. Here are 4 cases that we have looked a little bit into. So it's hydrogen production at the Prim refinery, pulp and paper, Nordirlandsverket, and the aluminum plant Hydro. And you can see here also that typically when you look into this, you will not typically capture technology like the one Anders showed can capture easily more than 90% of the off gases in a stack. Also when you use post-combustion or oxy-fuel. But in these different plants, you will have different number of stacks. You will have different concentration in the flue gas, and therefore you will arrive at typically different rate. So the left axis there, net CO2 capture on plant level in percent of the total emission from the plant will vary. And also the amount of CO2 captured, in this case, is post-combustion, so using a solvent on the flue gas. So that is something also depend, of course, on the cost you want to put into this, or depending on the carbon price perhaps that you have. We have looked at the Nordic industries, and this came up in a discussion here with the cement, iron and steel, and pulp and refineries. The Nordics, including Sweden, have large point source and emissions, and especially in Sweden. Of course, the transportation sector is a tremendous challenge. Also, the industry and energy-intensive or base material industry is a challenge. So here we looked at the Nordic countries, and you can see from 2010 to 2050, when we typically will have 8% reduction in emissions to comply with a possible EU ETS scheme that works. And you can see if we make some efforts here, we maybe reach halfway to the emission cap. You also see over-allocation there in the beginning of the period. So it's, as you know, it's about €5 per ton of carbon to emit a ton of carbon today. So then obviously, if you apply CCS, you couldn't comply with this. In the steel industry, of course, there is another route possible with hydrogen. As you probably heard of this Vattenfall, SSAB and LKAB initiative. We are also looking into that, but that is rather long term and depend also on the development of electricity system. So that's quite much challenge. And of course, there will be a significant cost due to increased energy use in this capture, and when you apply capture, and of course you have to handle these volumes of carbon dioxide to transport. We have looked in different products at different transportation. You can do, as I mentioned, with ships. You can also have some pipeline system out to this offshore storage sites. And typically in the Nordics, the transportation cost will be higher, maybe in the order of €15 per ton or something like that, because the point sources are, after all, a bit smaller than a large, for instance, coal-fired power plant. Here I come to a positive message, I think. And that is, of course, well, the negative is that, as I mentioned, it's about €5 per ton in the EU ETS trading scheme. So, of course, it won't happen. Nothing would happen, because we need really to follow these trajectories that was discussed. We need these transformative changes, like CCS and also in the other industries. So EU ETS will not deliver that. So if you take cement and steel, if you apply, say, it will cost around €100 per ton, roughly, to remove all emissions from these processes. Then the cement will be 70% more expensive, and the steel will be about 25% more expensive. So that won't happen, because you can't sell it in a competitive market. However, if you have some scheme where you, from sort of a consumer-driven perspective or procurement-driven perspective, you allocate that cost to the end product, that will result in about less than 0.5% price increase, meaning that it's just a way to show that solving the whole issue about climate is not a big part of the overall value creation in the economy. So that, we think, is a way forward when obviously the classical instruments have failed or will fail. So that we will, I'll come back to that. So if I just list a little bit, it's boring with these bullet points, but these are some examples of the research we're doing with carbon capture and storage at Chalmers. So we do what Anders showed. We have detailed basic or technical research on the chemical looping capture, but also oxy-fuel combustion. We also have some analysis on the post-combustion, meaning that we go post the combustion process or the process to so to say wash out the carbon dioxide. We have process integration studies looking at how you can best integrate different types of capture technologies that I showed in some previous slides. We also have energy systems analysis looking at what we do role in different markets and different sectors of carbon capture and storage as an overall mitigation portfolio. Then we also have significant spin-off research based on the carbon capture process, for instance, the active battery material products, and also some industrial. We look, for instance, at rotary kiln combustion in the Alcabis rotary kiln furnaces and pressurized flue gas cleaning. So there are a number of other innovative ideas, I think, created by these projects. So if I sum up about CCS, well, it's required if Sweden should take lead in reduction of carbon emission from energy and industry. And there we can, of course, use what Anders showed and the possibilities also to apply it on biogenic emission sources. Chalmers and, of course, various companies have a high knowledge in process technology and combustion technologies, so that gives a good platform to be a forerunner here. Because it's a fact that if the world would move towards the Paris Agreement, there will be a tremendous demand for CO2-free products and services. That's just a fact. Of course, the risk is, of course, that if Sweden do all this and nobody else cares, then, of course, that's not good. But then we are sort of fucked up anyway, so sorry about the language. Policy measures, yes, I think we need a new way of pricing CO2 emission. And of course, in some sectors, there are already, I think I was in this piece in Dagens Nyheter, they're only driving force. They want, make their procurement of, say, transportation, they go to logistics company, ask what is the climate impact, and then maybe the logistic company go to Scania and Volvo and ask what's the climate impact if we buy trucks from you, and so on. They go to SSAB maybe. It hasn't happened on a broad scale, but there are these trends today. So I think that is, and also Sweden has in the Miljömålsberedningen and Energikommissionen said that there is a strategy needed for the base material industry to see how we can achieve zero emissions. Because Sweden so far is very good at putting up, which I think is good, aggressive targets which are in line with the Paris Agreement, so that's maybe not that aggressive, but it's good. But we really have to show that we also can not only do in the sectors that we have good conditions. I should say, final slide, we have a new Mistra project, Mistra Carbon Exit, involving lots of industry, where we'll look at this and sort of supply chain or type of analysis, looking how technologies impacts on emissions and also pricing of emissions, how that can be done. And it involves both technical university, Chalmers, there is one in Stockholm, KTH, I think it's called, and then it's University of Gothenburg and some other, and the IVL is the coordinator and some other institutes. Yes, that was all.